Wikipedia defines encapsulation as the bundling of data with the methods that operate on the data, or the restricting of direct access to some of an object's components. Encapsulation is used to hide the values or state of a structured data object inside a class, preventing direct access to them by clients in a way that could expose hidden implementation details or violate state invariants maintained by the methods. While the word encapsulation in the definition may be intimidating, the concept is really not a hard one to grasp. Essentially, encapsulation occurs when creating a class that contains class variables and methods that can modify or operate on these class variables. Encapsulation is important because it allows the ability to secure instance data, or more importantly, it allows the ability to set guidelines of any code or client that may want to access instance data. Let's look at an example of how encapsulation can be useful when trying to limit access to instance data. Here we have a class called student. Within this class, we will make 4 class variables. All 4 variables will be of the string type. The first one will be used to hold a first name, and we will call it fname. The second one we will use to hold a last name, and we will call it lname. The third we will use to hold an address, it will be called address, and the last we will use to hold a student ID number, and we will call this variable idnum. If we hover over one of these variable names, we can see we have the option to create the getter and setter for our class variables. The getter and setter methods make good examples of how encapsulation is utilized to set the guidelines of how our instance data can be accessed. So we will go ahead and add these for all our methods. Looking at the set methods for our instance data, you can see the this keyword is used to set the values of our instance data. You may be able to guess why and how this is used here, but for now, to avoid confusion, I'm going to change the name of the string variable within the method parameters and remove the this keyword so that our code is aligned with where we are within the series. We will discuss the this keyword in a future video, but for now we will make a few changes. And lastly, we will add our constructor and our toString methods just to keep up with the habit. After that, our student class is complete. Now we will create a class called records, and we will use this class as the entry point for our program, so we will include the main method stub. First thing we will do is create a new student object called student1. Let's go ahead and create a print line statement to print out our object. And we can see our constructor and our toString methods are working as planned by looking at the format of the output. Now, let's try to access the fname variable directly from our student1 object. If we type the name of our object, student1, followed by a dot, we can see everything that can be utilized through this object. If we start to type the name of our variable, fname, we can see the only results we get are our get and set methods we previously created. If we disregard the fname variable not being here and we continue to try to set it to a new value, we can see we get a red line under our fname variable. And if we try to run the program, we can see our error states the field student.fname is not visible. This is good. This means encapsulation is doing its job as a result of how we implemented the student class. Now, if we were to change what is called the visibility modifier of our fname variable to public, our code will work. However, this is often not a safe practice. Note that we have seen 2 visibility modifiers, public, which is used in cases where we want to allow the variable or method in which the modifier is applied to be referenced externally, as in this modified case, and private, which is used in cases where we want to limit reference to a variable or method to within the class it is declared, as seen in our first case. Let's set the access modifier back to private and go inside our set fname class and talk about how encapsulation can be utilized to implement security features. I've created a print line statement that prompts the user to enter a password. We can then implement an if statement, something we will discuss in a future video, to validate the password before we actually set the variable. This is an important ability and one that is made possible through encapsulation.